Dear students, so we are going to see the next topic in the unit number 3, vehicles and its specifications. So in this video, we are going to see the different engine specifications, how we can specify the IC engine, that is internal combustion engine. And then we will see the vehicle specification for two-wheelers in this video. And the other parts, so that is vehicle specification of four-wheelers, or you can say light motor vehicles, we will see in the next video. So let us start with this video. So first, what is meant by now we'll see what is meant by a study of engine specifications. So in engine specification, what are the different parameters that are used for engine, specify an engine, or you can say IC engine. So first parameter is a fuel type. So fuel type indicates the type of fuel used in engine. Okay, so this is the first parameter which is used in engine specification, that is fuel type. So it is a type of fuel that is used in engine. It may be petrol engine, diesel engine, or it may be a gas engine, or it may be any other fuel. So that fuel is specified, or type of fuel is specified. So this is the first specification. Second is engine type. Now first one is fuel type. Next one is engine type. So the engine type indicates the method of cooling the engine. So first is in engine type, we have method of cooling. Either it is air cooled engine or it is water cooled engine. Okay. So this is method. In engine type also we have second, it is the working cycle of the engine. It may be 4-stroke or it may be a 2-stroke. So this 2-stroke and 4-stroke, it is a main important parameter in case of engine type. So this fuel type first and engine type, it is the second parameter that is most commonly used in to specify the IC engine. Next, we have bore and stroke. Now, this specification, all these specification, they are technical specification, not aesthetic, not ergonomic specification is there. These are all technical, or we can say product specification. Next, it is bore and stroke. So next, now what is meant by bore? It is in IC engine, bore is nothing but the inside diameter of each cylinder, or we can say internal diameter of the each cylinder. So for example, here is the cylinder is there. So internal diameter of this cylinder, it is known by this bore. That is the DI. Okay. Or we can say sometimes it is called as a D. Next one is stroke length. Now this is another important parameter that is called as a stroke length. So stroke length is distance traveled by piston. Okay, so inside cylinder, the piston is travel from top dead center, that is TDC, to bottom dead center, that is the BDC. So the distance traveled by a piston when it moves from bottom dead center to topmost or top dead center. So this length or distance which is traveled by this piston, it is denoted as the stroke length here. So we have bore and stroke length. So if we know the value of bore and stroke length, then we can find out the value of displacement or engine capacity. So next important technical parameter, it is called as a displacement or engine capacity. Now it is generally, it is in cubic centimeter. So it is in centimeter cube, cm cube. And it is called as cubic centimeter, that is cc. So the capacity, or you can say displacement of the engine, it is based on the what is the cc of the engine, that is cubic centimeter, or you can say cubic say, centimeter velocity, capacity of the engine or displacement capacity, it is denoted by the engine capacity. So we will see this first. For that, we require to find out this cubic capacity, we require different types of volume. Now we have a CM cube, it is nothing but the volume. Okay, so it is the volumetric capacity. So first we will see the swept volume. Now what is meant by swept volume? It is generally denoted by V suffix S. So swept volume is the volume swept by the piston. So when the piston is moving from BDC to TDC or from TDC to BDC, the volume is swept by that piston along this length and diameter. Okay, so along this diameter as well as along this length, so that volume is called as swept volume. Okay, so this is the swept volume. Another volume it is called as generally it is denoted by pi by 4 d square into L. So it is area into length. It is nothing but the volume. A is the area into length. So length is the swept length L, or you can say stroke. So area is cross-sectional area. It is circular cross-section. So area is pi by 4 d square, and into length it is the stroke length. So from that we can find out the value of swept volume. Now another type of volume, it is clearance volume. Now above the piston, we have a piston head, and in that piston head, other components that are fitted like inlet valve, exhaust valve is there. So this is inlet valve, exhaust valve, sometimes spark plug is fitted. So clearance volume is the volume between the piston top. So at this top dead center, so from this top dead center to the cylinder head. So from this top dead center to this cylinder head, this volume is called as clearance volume. It is generally denoted by VC. So clearance volume is the volume between piston top and cylinder head when piston is at top dead center. So the clearance volume is the volume of cylinder that does not swept by the piston. Okay. So in this, from top dead center to head of the cylinder, there is no movement of piston. Okay. So because of this, it is called as a clearance volume. So this volume is the clearance. So when position is at top dead center, it compresses entire air and fuel mixture in the clearance volume before combustion takes place. So it compresses up to this point, and after that, there will be combustion takes place. The air fuel mixture, it compresses before it air combustion takes place. So in this clearance volume air, the compression will be takes place. So the displacement, now we have a displacement or engine capacity. It is combined swept of volume for all cylinder. Now if you have a number of cylinders in an IC engine, it may have one cylinder, it may have two cylinder, it may have three cylinders. So if you have to find out the displacement capacity or engine capacity, then it is found by the combined swept volume of all cylinders. So therefore, the displacement or engine capacity is equals to swept volume into number of cylinders. So swept volume is pi by 4 d square into L, into N is the number of cylinders. So we take one example how to find out this engine capacity, or we can say the CC of the engine. So for example, if I have a bore diameter D is equals to 73 mm. So it is in centimeters, 7.3. Similarly, we have stroke length L is 89 mm, that is 8.9 centimeter. And we have a number of cylinders are 4. So N value of N is 4. Now put this value we get displacement is equals to pi by 4. D is 7.3 square into L is 8.9 into number of cylinder is 4. So after calculation, we get displacement as 1490 centimeter cube, or we can say it is called as a cc. So 1490 cc is the displacement or engine capacity for this engine, which having 4 cylinders. Okay. So this is the parameters, generally fuel type, engine type, bore and stroke, displacement. Now next important parameter, it is the maximum power. Okay. So what is the maximum power produced by that engine? So that is the specification. So figure shows power speed characteristics. So if you see this curve represents, so red line curve represent power versus speed characteristics. Now if you see power is in kilowatt, if you see in this power is in kilowatt, that is 20 kilowatt, 40, 60, 80, 100, 120. And your speed it is in 1000 RPM, 2000, 3000, 4000, up to 6000. So if you see, as we increase the speed, the power is also gets increased. Now it is increased to a maximum capacity. So for example, here it is the maximum capacity. So here Pmax is there. And at this speed, we have a maximum power capacity. After that, if we increase the speed, power goes on decreasing. So this is called as a maximum capacity of the power. That is the Pmax. And the power, the capacity at engine having a maximum capacity of power, that speed at which this maximum capacity is happen, so it is called as the maximum speed. So this both values are specified, that is Pmax and the Nmax. So the engine performance, or we can say performance of engine, is in terms of power. Another important term is torque. Next, we have speed and fuel consumption and efficiency. So these are the engine performance parameter, or you can say these parameters are very much important. And based on these parameters also, we can evaluate on the basis of purpose why we use this engine. So based on that, we can have different engine performances there. Now, for example, one of the example is there. If we have a tractor engine, okay, so in case of a tractor engine, if farmer needs to move, if farmer needs more power to pull the tillage implement, or you can say tillage implement, it must have a drawbar power. It must have a high drawbar power. And similarly, if it required more power to do farm operations using rotary power, then engine in a tractor must provide maximum power. That is maximum power, torque, and output speed also. Okay. So that is the difference between this one of the examples where these parameters are very much important. Next, to relate this engine performance with economy of usage, next important parameter, it is called as specific fuel consumption. So this specific fuel consumption is determined to have economy of the usage of the fuel, also the engine performance. So in automobile engine, as engine speed increases, if you see in this figure, as engine speed increases, power output of engine gets increased. So as like engine speed increases, power gets increased. So from, say here it is 800. So from 800 to 5000, or we can say 5500, the power gets increased. Now it becomes maximum at certain speed, that is called as a NP speed. That is speed at which power is maximum. And it again drops down as we increase the speed further. Okay, so it gets drops as we need or we have increased the speed. So in specification of automobile engine, this maximum power and corresponding engine speed, they are given because it is very much important parameter in case of the engine to measure the performance of the engine. Now, similarly, we have maximum power. Similarly, we have maximum torque. So if you see in this figure, the another curve which is shown by this blue line, which is the torque versus speed curve. So here we have a torque that is 80, 120, 180. It is in Newton meter. And here you have speed. So similarly, as like power, torque speed characteristics of automobile is very much important. And if you see in this automobile engine, as we increase the speed, the torque is also gets increased up to a maximum torque. And at this, we have another speed. So that is called as speed at which torque is maximum. That is say NT. So it becomes maximum at this engine speed. Say NR, we can take this NR or it can say NT. Now it again drops from this speed if we increase the further speed. So again torque gets drop from we increase the speed, say for example 3600 to 6000. So in this speed range, your torque gets decreased from maximum torque to a decreased torque. So in specification, the maximum torque and corresponding speed, that is speed at which there is a maximum torque, both are specified. So this specification is important. Maximum power at speed and maximum torque at speed. Now next important engine specification parameter, it is the number of cylinders. Okay. So based on number of cylinder, we can find out the capacity of the cylinder. So that number of cylinder is also important parameter. Next parameter is valves per cylinder. So it indicates the number of valves which is used in per cylinder. Generally, we require 2 valves per cylinder. So it indicates the number of valves which is used in each cylinder. That is number of inlet valve and number of exhaust. Next, fuel supply system. Next parameter, engine's parameter is the fuel supply system. So it indicates what is the type of fuel supply system which is used in vehicle or automobile. What is the type? So for example, in case of diesel engine or CI engine, MPFI system is used, that is called as multi-point fuel injection system, or it is PGM-FI system, that means the programmed fuel injection. Okay, so PGM is nothing but the program, FI is nothing but the fuel injection. So we have either MPFI system or PGM-FI system. So multi-point fuel injection system or programmed fuel injection system. Now this system is used in SI engine, in CI engine, and in SI engine we have carburetor. So many automobiles or engine manufacturers use their patented name, that is called as PGM-FI. That is nothing but the programmed fuel injector, or you can say programmed fuel injection system. Now, next is compression ratio. This is the last parameter that is very much essential for engine. It is compression ratio. Now, compression ratio of IC engine, it is nothing but the ratio of total volume divided by clearance volume. So total volume is nothing but the swept volume plus clearance volume divided by clearance volume. So it is nothing but the compression ratio. So So compression ratio is defined as the ratio of total volume of the cylinder to the clearance volume of the cylinder. So it is the dividation of these two terms. So we get total volume is nothing but the swept volume plus clearance volume divided by clearance volume. So we get compression ratio as Vs plus Vc upon Vc. So Vs is swept volume, Vc is clearance volume. So from that we get the compression ratio. So these are the parameters that is very much used to have a specification or to have a specified engine parameter mainly. Okay. Now, if we have higher compression ratio, then we have a higher thermal efficiency of the engine. तो जितना आप compression ratio higher करेंगे उतना efficiency of the automobile engine gets increased. Okay, so it is directly proportional to the thermal efficiency. Now next is we have for example one of the engine specification parameter is there. So let we see one practical example of engine specification of Honda City engine. Okay, so how this Honda City engine it is specified. So for example, this is Honda City car, and in that car we use a Honda City engine. So this engine is there inside this car, that is the Honda City engine. Now for that Honda City engine, the first parameter is fuel type. That is, which is type of fuel is there. Either it is petrol engine or diesel engine. So here we use petrol as a fuel. So fuel type is petrol. Second specification parameter is the engine type. Now engine type is water cooled. So cooling system is there. Then we have a 4-stroke engine. So number of working stroke is there. And the fuel type is also mentioned. That is petrol engine. Okay. So we have engine type water cooled 4-stroke petrol engine. So water cooled is cooling system which is used in engine. Number of stroke used in engine, that is 4-stroke, and type of fuel, that is the, we can say, spark ignition engine or petrol engine also. Okay, so it may be a SI engine, sometimes it called as a petrol engine also. So it is water cooled 4-stroke SI engine, that is spark ignition engine or petrol engine. Next, we have a displacement capacity, that is in CC, it is given as 1497. So this is the displacement capacity or engine capacity. Next, we have maximum power at speed. So maximum power is 117 bhp. Now bhp, it is nothing but the brake horsepower. So it is nothing but the power produced at output shaft of the engine. Okay, so it is called as a brake horsepower. It is called as a bhp. So we get a maximum power, that is 117 bhp, or you can say HP, at 6,600 rpm. Next parameter is maximum torque. So it is 145 Newton meter. Again, the speed is 4,600 rpm. So if you see, always in case of maximum power, speed is maximum. In case of maximum torque, the speed is less than your maximum power. So this is the next important point to be noted. Next, we have a number of cylinders. So in this, we have 4 cylinders are used. And so because of that, we increase the number of cylinder. So displacement capacity gets increased. So it is 1497 cc. Next, we have walls per cylinder. So per cylinder, we have 4 walls. Okay. So there are 2 inlet valves and 2 exhaust valves. Next, we have bore and stroke. So the bore, that is diameter is, we can say internal diameter or inside diameter, it is 73 mm, and 89.4 mm it is the stroke length. So again, from this formula, we can find out this displacement capacity, that is pi by 4 d square into L into number of cylinders. So from that, we get this value as like. And the last column, the second last parameter, it is fuel supply system. So we, in this engine, a programmed fuel injector system is used, that is PGM-FI, programmed fuel injector. And last is compression ratio. So for this Honda City engine, we have compression ratio as 10.3:1. So total volume is 10.3:1. Okay, so this is nothing but the compression ratio. Okay, so this is an practical example for engine specification that is we have seen in this video. Now, again, I will make this video into two parts so that we'll get idea of different parts. So in first part of this video, we have seen the study of engine specification. Now in a second part of video, we will see we can say specification of two-wheelers. Now, what are the specifications required for two-wheelers? What are the different parameters which is used for specification of the two-wheelers? So I will stop here. Now, those who have not subscribed my channel, please subscribe, and also please like the video also. Thank you. Thank you.